Assalamu alaikum. So in this video we'll have a quick review of the class diagram, and we'll take a small example. So the example says draw a UML class diagram that models the relationships between the following classes: mall, store, salesperson, department, manager, merchandise, store catalog, store website, and customer. The important thing when drawing a class diagram is to look for the most important or the highest level class and start by drawing that class. So the most let's say general class here is the mall. So we can start drawing the mall, and then we have the store, and the relationship between these two is clear. We know that a mall is made of many stores. So we'll draw this class. We'll start by a mall. So this is the class mall, and a mall will have a relationship between a mall and a store. And the idea here is to try to select what kind of association, what kind of relationship we'll have here. So the relationship here is a strong relationship because a mall contains many stores, and a store in this scenario here only exists inside this mall. So if we remove the mall, all the stores they disappear. So this will be a containment. It's not only an aggregation. So it's containment, which means that stores does not exist outside of a mall. And we need to specify also the multiplicity of this relationship. So here we have 1 to n, let's say, or 0 to n, 0 star stores. And here we have one mall. And we need to also specify the navigability, which means that from which object we can navigate to the other. From the store, we should be able to navigate to its corresponding mall, and from the mall we should also be able to navigate to all the stores that it contains. So in a Java program, for example, we will have a mall. We will have a mall object. We'll have let's say a list or a collection of stores references inside it. So we can imagine that this link is navigable in both directions. Okay, so let's go back to the other concepts that we have. We have salesperson, department, manager, merchandise. Okay, so salesperson usually works in a store. So a store will have, let's say, salesperson, sales person. So this will be a class. And what's the relationship between salesperson and store? So salesperson works in a store. What kind of relationship here? It's not a dependency, because a dependency is a very weak relationship between classes. Usually we use dependency when, for example, this class is using this one inside one of its methods as an argument type, or as a in the body of one of its functions here. So this is not the case here. There is a stronger relationship. It can be an association, but it can be an aggregation or a composition. So aggregation and composition, they carry the meaning of the whole part relationship. So here we do not have this meaning of whole part. So this is only a simple association. A store has 0 to n. This is a star, 0 to star, which means n persons, and a person works in only one store usually. And also from a store we can have a list of the salespersons that work in the store, and also a salesperson has a reference to the store it works on. we can have this navigability relationship. Um, okay, so what about the next concept? So we have department manager. So here we have departments. So a store may have different department, and here the whole part concept, the whole part idea is there here. So store is composed of departments, and if the store disappears, the department disappear also. So here we have clearly a composition, not only an aggregation. It's a composition relationship. Also here we have 0 to star, and here we have 1. We may have double navigation here. Then a department has a manager. It's not specified in the use case, but we can imagine that a department has only one manager. What kind of relationship here? It's not, there is no whole part idea here. There is a simple association, a one-to-one association. So a manager manages one department, a department has one manager. So of course, depending of the cases, we may have different numbers, but let's imagine that in this situation here, we have, and in this system here, a manager can only manage one department. And we can have a double navigability here, bidirectional navigability between these two classes. And then what should we have also? Merchandise, store catalog. So what about merchandise? Usually merchandise is related to store. So store sells merchandise, and here the association is it's only an association, and a store sells different merchandises, and merchandise can be is sold by one store. If something is sold by a different store, usually it will have a different identification, so it's not considered as the same merchandise. And here, usually there is no direct relationship between these two. There is no navigability between these two items, but usually we have what we call an association class, and this association class will define how many items we have of each element of each merchandise in the store. So it's not defined, or it's not specified in our specification, but we may have something like this. We may have like stock association class that will have the number of items available. Number of items available of this merchandise in this store. Then we have store catalog, store website, and customer. So a store has a store catalog. Usually store has many store catalogs, 0 to star, and then here store catalog here is linked to one store. Usually we have navigability in this direction, which means a store catalog has a reference to its store, but the store inside the class store we do not have a list of all its store catalogs. So we do not have the navigability in that direction. So if we want to specify that we do not have the navigability in that direction, we may add this little cross here to say that in this direction there is no, the association is not navigable. And then we have a store website. Also here, a store has one website, let's say, and also one website is linked to one store. Here we have bidirectional navigability between the store and the store website. I did not specify the roles of in the associations. We may do this at the end. And then we have customers. So customers usually are customers of store. So we may have class customer, and the customer usually is a customer of one store. So a store may have 0 to start customers, and one customer may be the customer of one or more stores until he is a customer of at least one store. To call him customer. So there is no navigability between the two, but we may have, usually when there is no navigability, usually we will have an association class that will have data about what happened between these two classes. For example, purchases, like this customer have purchased some items from this store, so we may have some details here about that link these two classes together. And then let's go back to the roles of the relationships. So usually we have to specify the roles that this class is playing for in this association. So here this is my mall, for example, and this would be my store. Here we would say this is my store, and this is my this is a department. A department would have my manager. This is the role that this class is playing in this association, and if we generate Java code from this diagram, we should have a property called my manager in the department class, which type is a manager. So this would be the name of the property that would represent this association. And here we would have, let's say, department, and so on. So I think this video is enough for to review class diagrams. So I stop here.